right, so let's see. Let me get all this stuff plugged in. Unfortunately for you all, I'm both a morning person and very enthusiastic about this topic. I'm really, really excited. I'm just going to say that I might go too fast. I'm not entirely sure, but I'm going to be around later in case you want to talk about stuff that I'm talking about here. Okay, so today we're going to talk about human performance, I'm just going to get right into it. Here's a bit of a roadmap of what we're going to talk about today. First, I'm going to talk to you a little bit about what research in human performance looks like, especially in our field. Then I'm going to talk a little bit about incidents and have some, is that like a flicker thing? Not flicker, but like a flickering thing. Oh, that's a bummer. Anyway, we're going to talk about incidents, and not from the perspective that you're probably used to. And so there might be some sort of surprising perspectives there. And then finally, hopefully, what does this mean for you? It's not just that I want to talk about this just for the sake of talking about this. What could it mean for you in an organization? So this is a little bit about me. There's some places that I've worked, some things that I've written. Of particular note for this talk, my master's degree was a couple of years ago now, was at Lund University, and it was in human factors and system safety. And my thesis was studying engineers resolving outages, and specifically what rules of thumb, what sort of heuristics do people use. And so this leads us to, when I say research, these fields, human factors, system safety, cognitive systems engineering, resilience engineering, you may have heard some of these. In fact, you might have seen me speak about some of this, and if you have, that's great, or others. The DevOps community has drawn the attention of folks from these fields, and I am proud to say that I'm partly responsible for that. And I think that this is a good thing, and we'll talk a little bit about why. So what does this look like? Well, a couple of years ago, I got together with Dave Woods and Richard Cook. These are folks from cognitive systems engineering, resilience engineering. And Dave came to Velocity, gave a talk, and said, just was absolutely blown away by this community of practice, and he said, well, we asked him. I said, well, what do we do to sort of further this? I mean, I was getting my master's. I was inviting as many folks from those worlds to speak at conferences, and he says, well, we'll do what we did, in aviation, do what we did in nuclear power, and we have a consortium. So that's what we did. And it was an academic industry partnership, and where the funding comes from companies out in industry. In this case, the first cycle was IBM, Etsy, and this trading exchange called IEX in Manhattan. And there was a year-long project, and the topic was coping with complexity. And it was meant to be a sort of a painting of a landscape of what does it look like when people have to unravel what's happening, where there's lots of ambiguity, there's lots of uncertainty, not just what's happening, but also what to do and whether or not you will make it worse. So they looked at an incident from each of these organizations, drastically different organizations, and did all of the things that this research community does: cognitive task analysis, amongst other sort of super technical sounding terms. But they studied cognition, and what they found are these common themes, and these are themes that were agnostic to the organization. And so the result was a published report called, it's now known as the Stellar Report, named for a snowstorm that happened to hit when we had one of the workshops in Brooklyn. If you haven't, raise your hand if you've heard of the Stellar Report. Okay, if you haven't, please check it out. I think it's well worth a read. So there's a bit of a side note here. So these fields that I'm talking about are grounded in real work, which means that there's really no such thing as purely academic, right? Like, say, traditional psychology or mathematics. In these fields, most people are what would be known as practitioner researchers, right? And we're beginning to see, I'm happy to say, more of practitioner researchers in this domain. Paul Reed, who's also enrolled in the program at Lund University in Sweden. He's finishing up his thesis. Nora Jones, who is at Netflix, is currently enrolled. Casey Rosenthal, who's also at Netflix with Nora, is enrolled, and Jessica DeVita is not far behind. I certainly know a number of people who are also looking to up their game and really become curious about what this looks like. So in order to tell you what's been found thus far, which again is a short period of time, but because these folks have done a lot of research in other what's known as high consequence, high tempo domains, there are a lot of similarities, there are a lot of differences, and they're just really good at this. In order for me to tell you about that, I kind of need to set this stage and sort of get a picture of what we're talking about. I need to describe the where and the what of this work. And so follow me here for a couple of minutes. We're going to start with this description of your work, right? And there's going to be two parts. There's going to be an above the line region and a below the line region. And so typically what we see here, it's common to think about your service that you're providing for customers or no matter what you do. And in this diagram you see here the people using your service. And in this sort of bubble here, don't think of it as a cloud, but sort of like a bubble, you see things like your website or your app, your API or other services. And that contains code, right? It contains sometimes code you wrote, sometimes code other people wrote, data, the network it's delivered on, some means of delivering it. And so, but of course you wouldn't believe me, and especially this crowd wouldn't believe me. So like say, oh yeah, that's the system. Well, that's obviously not the system. In fact, actually that's not where we have our attention. That's actually not really what we talk about a lot when we get together. So if we look a little bit closer and sort of expand up, right, we can see that it connects to all the things that you use to make this service work, right? And here we've got deployment tools and code repositories and testing tools and monitoring tools, all of that sort of thing, right? And you could say that this is the system because many of you spend much of your time focused on those things that are not inside the little bubble there, but the things around it, right? This is a topic of lots of conference presentations. But if we stay there in this sort of model of the world, we won't actually see where real work happens. And I'll tell you what I mean by this one. So what we're going to do is we're going to just draw a line here across the top, and if we call this line the line of representation. And if we draw that, we can see you. This is you. These are all of the people who are getting stuff ready to do. They are making changes, they're adding stuff, they're subtracting stuff from all of the things that are happening below the line. They're doing the architectural framing, the monitoring, all of that sort of thing. And they're keeping track of what's happened in the past, what's happening now, what's happening in the future. And so you'll notice, by the way, that each one of these people does not have the same representation, right? They have some sort of mental representation of what's going on below the line, some sort of picture. If you look closely, you'll see that none of them are the same, right? And this is really characteristic of these roles. And nobody has the same representation. So to summarize, if we zoom out a little bit, and we play this out a little bit further, we've got your product, service, all the stuff that you use to manipulate what's happening in that blue area. And then here, and I think what I really want to get across is this is where work gets done. So this is our model of the world as researchers, and it includes not just the things that are running there and the kinds of activities you're performing, the cognitive work that you're doing to keep that world functioning. Well, if we play this with this a little bit more and I'll sort of elaborate, we end up with this sort of model. So this model has this line of representation going through the middle, and you interact with the world below the line via a set of representations. Here's the thing. Your interactions are never with the things themselves, right? You don't actually change the systems. What you're doing is you're interacting with a representation. That representation could be a terminal. It could be a dashboard. But it's a representation of something about what's going on below. That's what tells you all of the information that you get about what's happening below the line is via these representations. And as you can imagine, there's a lot happening below the line. So therefore, these representations are really just like a little keyhole, right? So the only information you have about these systems, about the system, comes from these representations. And all of the things that you're doing, the reacting, the modifying, the anticipating things, the inferring, has to be done via those representations. They can't be done any other way. So there's a world above the line and a world below the line. And although you and I mostly talk about the world below the line as though it's very real, as though it's very concrete, as if that's the thing, here's the surprise. You never get to see it. You actually never get to see that stuff below the line. But we treat them as absolutely real. It doesn't really exist. I mean, it does. In a real sense, there's no below the line that you can actually touch, right? You never, ever see code run. What you see are footprints in the sand via representations that were programmed to show you those footprints in the sand, right? You don't actually see, when you see a train go by, you see the train go by. You don't see code executing. You see an entry in the process table. You may see the logs that it generates. And what you do is, it's not an imaginary world, it's a real world, but we manipulate a world that we can't see via these representations, via these little keyholes. And that's why we have to build these mental models, these conceptions, those understandings about what's going on. Those are the things that are driving the manipulation. It's not the world below the line that's doing it. It's your conceptual ability to understand the things that have happened in the past, the things that are going on right now, and the things that you might be doing in the future, and why those things matter. So once we adopt this perspective, once we step away from the idea that below the line is the thing you're dealing with, and understanding that you're really dealing with above the line, all kinds of things change. And this is what this research looks like. We look at the stuff at the top. This is what we look at. Cognitive activities. Nothing happens below the line without them, right? These cognitive activities in both individuals and collectively in teams, both up and down in an organization, are what makes the business actually work. So I've been studying this in detail along with some colleagues, and I can tell you this, it doesn't happen the way we have always imagined it happens. Now, so I got to back up here because and say that what I've described here is I've got some boxes and some lines and some icons or whatever. We're certainly enamored because we cannot see below the line. We are all used to, in our day jobs, we work with models. We work with abstractions. We work with things, concepts that represent other concepts, right? We don't talk about binary. We don't talk in, some of us might talk in assembly, but even then, those are never really productive conversations anyway. But to add a bit more here is that all of the most important part of this idea is that all of this changes over time. So it's not just that you have a mental model. Oh, I have a mental model and I draw it on the, with the boxes and lines and arrows on the whiteboard, and this is what it looks like. Well, no, that's actually not true, because that is the conception you have of how the system hangs all together with the different components and how it behaves and all that sort of thing. But it's also contextual to when you draw it. If you were to say, oh, what does it look like on Cyber Monday at Etsy versus versus any random Tuesday in June at like 6 in the morning. What you're concerned about in your perspective, your model of the world may be different. So this is the unit analysis I want you to have in your mind for the rest of this talk. One bit clarification, I want to get at what is represented above the line. It is not management. It is not organization design. It's not reporting structures. It's not culture. It's how people work, and by that I mean cognition. So with that frame, we can ask questions like this. How does our software work actually versus how it's described in the wiki and in our diagrams? Because we know that those aren't comprehensively accurate. How does our software break really versus how we thought it might break when we put in all those fail-safes and safeguards and that sort of thing, and monitoring? What do we do to keep it all working? And so I'm going to ask this thought exercise. Imagine your company. What if your companies today, right now, stopped making any changes to any part of your system, including not responding to any pages? 0, hands off keyboard, fully. Raise your hand if you think your system will be up and working tomorrow. Keep your hands up. Wait, keep your hands up if you think it will last 2 days, a week, a month. Yeah. Yes, so all the people who have their hands up, oh yeah, don't have to touch it. It'll be working in a month. I would like to talk with you later. So we study incidents. So that's the frame. That's the frame. Now, incidents. We study incidents, but for not maybe the reason you think. There's a couple of reasons why. If we're looking to understand cognition, incidents tend to bring everyone's attention to a specific place in time. This is important because we need to have some high degree of confidence of where people's attention lies, right? The other thing that makes them interesting is that all incidents are surprises, and so they show us where our understanding is inaccurate. That means that it's a contrast. It's a contrast between what we expected to happen and what actually happened. This, by the way, is how a joke works, right? The contrast between what you expect to happen and this unexpected humorous response. Cognitively, that is the place we want to be. For a cognitive systems engineer, what you want is to be inside that. Incidents can have many influences on an organization, and a lot of them sort of escape us, and we'll talk a little bit about that. Most of them are invisible. So there's 3 things that I want to, let's see, will I make it to 30 minutes? All right. How we think incidents unfold. It's quite common to think about incidents unfolding this way, right? But this is of convenience, by the way, because if we were to actually look at how incidents unfold, it looks a lot messier than this. In which case, I would make an argument, a hypothesis, that this is a classification exercise, which makes it easy for us to do something else with, but certainly not represent the actual accident. So let me just take a look at an actual accident, an actual incident, okay? So we've got some sort of phase that you have something is seemed or detected to be abnormal, right? And then some long period of time where there's some debate about whether or not it's worth paying attention to. Something can be abnormal, detected to be abnormal, and also fit within a frame that says, oh, well, maybe it's not actually maybe this is a normal variation, right? Regardless, you know what, let's just keep an eye on it. It might recover, it might just, it's just this, there might be something weird with traffic, or there's some queuing, blah, blah, blah. But over time, whatever's happening ended up getting worse. And so that at some point, yes, this is an acknowledgement, we have to do something about this. And so what we'll do something about it, and then we'll repair it. So now in this example, which is, by the way, a pretty simplistic representation of an incident, is from an actual incident. And what this illustrates is that there can be a very big difference, and not always, between detecting a problem and identifying a problem, or assessing the implications of, or the consequences of a problem. So let's take oh, and by the way, you always spend some, and in this case, spent some period of time to actually do some work to confirm that what you've done actually did the thing. That's not represented in the simplistic model. Let's look at another one. So you notice something's getting critical, right? You come up with some plausible explanations what's happening. You may spend some time to test these hypotheses along with your coworkers, and you end up with, you know what, it's C, it's got to do this. And then as you start to do C, you realize you get some feedback, right? What would be known as a therapeutic, what's known as a therapeutic intervention, turns out to be a diagnostic intervention. And actually you get some feedback like, oh wait, actually, you know what? B and C were pretty neck and neck with our hypothesis, and you know what, it actually turns out. So now actually, we got to work on B, and we got to figure out what we did earlier. So now you can imagine this doesn't, and we have to confirm it's actually fixed. And so you can imagine that, sorry. You can imagine, raise your hand if this looks familiar to you. Okay, look, by the way, this is still simplistic because one, it's linear, and two, I'm going to represent an entire team with one line that goes cause and effect. That's not actually the way it works. Well, let's take a look at another one. Let's say there's no ambiguity. The event is clear, but then there's some amount of time. Ambiguity doesn't have to be about what's happening. It can be about what do we need, who do we need to ask for help. Oh, and by the way, when we ask them for help, we have to spend some time and make a choice about bringing them up to speed or making progress on diagnosis, right? We have to figure out on what to do. Let's say we settle on doing X, and then we realize that X did, unlike C in the previous example, is actually making it worse. So it's quite often that then you'll now work in parallel. You're cleaning up C, but then you're also doing this Y, and you'll confirm. So now, familiar still? How's this simplistic, you know, detect, repair, diagnose, repair, done? How's that look? Because this is messy, and this is not even close to representing. I want to put a couple of things up on the screen. Under no circumstances am I expecting you to actually read them. This is a hypothesis-generated map by a friend, Dr. Matthew Branlatt, and what you see here is a map, process trace of red team, blue team exercise, okay? And so there's a timeline for sure, but then there's a whole bunch of other things, and all of these things represent cognitive activities. This is a map that I had in my thesis. And just on this is mapped out between different individuals of different teams on a timeline, the relaying of critical observations and the generating of hypotheses. So, do you want to go back to what this is called is dynamic fault management, and we already said that detection can be different and separate than identification. Hypothesis generation is dynamic and emergent. We love to think about troubleshooting diagnosis as person in front of a laptop, and if you can only, and with the challenge imagined to be, if you can only get the right graph or only get the right log line or the right, you know, sort of telemetry in front of them, that is the thing. That's not the thing, because that ignores the fact that almost no one these days does this engages with this activity by themselves. Matter of fact, a huge part, the phenomenon is known as cooperative advocacy, a huge part of hypothesis generation is when somebody is overhearing or being aware of two other people discussing a problem. Can inform hypotheses that I might generate. So they don't just come from here, they come from here. And interventions can have ambiguous or uncertain consequences. All right, I want to talk quickly through far-reaching influence of incidents. In almost all of your organizations, there was almost certainly, unless you're just started, an event that the old fogies remember. In fact, actually, that's the story they'll tell at the offsite and at the bar. And the reason why it's a great story is because it was super surprising, right? Incidents can have significant influence on medium or long-term business decisions, right? It can cause you to change your roadmap. It can cause you to change or take on new third-party vendors. Incidents can have you turn up or turn down your reliance or dependency on some other entity. Oh, and you might actually get reorgs that are influenced not insignificantly by an incident. You can imagine, and just because it's top of mind, you can imagine what sort of influences does, say, Equifax, right? Internal stakeholder, shareholder expectancies. These are sorts of things. Another thing is that it can influence perceptions of risk in ways that are really distant. The postmortem was over. It's already locked away on the wiki for, of course, nobody to read. But it may go through the lore, but staffing forecasts, priorities, budget forecasts, and to use the Equifax example only because it's salient, not for any other reason. You can imagine a world where if you were running security engineering at Equifax, you probably didn't have too much trouble getting headcount budget the day after the breach. Am I wrong? And then finally, influences on velocity and robustness of change. We're going, oh, the pendulum's gone too far. Or we need to do more continuous deployment, something. We may actually change what people are allowed to do. We might need to split this team off and actually have a dedicated team for this thing over there. Actually, some teams may say, you know what, scrap our roadmap, we got to focus on this, whatever. Incidents tend to bring, if they don't bring new regulations or compliance, at least internally they can bring new rules, new norms, new expectations. There's all kinds of things that are distant from the localized incident, but make no mistake, are absolutely influenced by that. So, some implications, some food for thought. So based on what we've seen so far, the second cycle of the Snafu Catchers Consortium is underway. We're going to be publishing something about that soon. I'm betting my current livelihood on doing this type of work in a consulting fashion. There are a couple of takeaways. Consider treating incidents as unplanned investments. Because if you think about it, that money has already been spent. You have already incurred a cost. It may be a reputational cost, it may be an economic cost. But and it certainly would be a stress marker for the organization. Getting a return on that investment means that every incident moves you forward. And human performance, the cognitive experience of people, are what you want to look at. Second, I think it's time that we need to confront that thus far we've been relying on what I would call shallow metrics. Time to resolve, frequency, severity, etc. These things are negotiable. They are actually, I think they're quite, and I would say in some cases, infinitely negotiable. What constitutes an incident to pay attention to, an incident to track, can be done for different purposes. The outlines that say this is a Sev 1 versus a Sev 2 is also very, very blurry and hazy. And in some cases, there are organizations where there are economic gain for it. We treat that as critically valuable data. It's not. It's data. It is not the critical data. The critical data are people's experiences. Here's a thought exercise. Imagine, and I really want you to do this, imagine if you were not allowed to collect time to resolve, frequency, or severity of events in your organization for a month or some period of time. My questions are, what would you look for in an incident? You can't lean on those. What would you lose if you didn't have them? Maybe what you might lose evidence or you might lose currency to bring priority or attention to something, in which case that's actually not about the event itself. This is for a political purpose, a very reasonable political purpose. But make no mistake, it doesn't tell you anything about the incident at all. How would you explore incidents if you couldn't look at those? Another suggestion, collect all the questions in your postmortems that are being asked, right? Take them out of the meeting and bring a bunch of people who facilitate those and ask, are some questions better than others? What makes a good question? What makes a bad question, right? Building a cadre of folks that can get practice in generating good questions. That is to say, getting people to say things out loud that they almost never do because they think it's obvious to everybody else. P.S. It's not. All that esoteric knowledge, their tips and tricks, what they thought they were doing, all of that stuff. And then finally, a suggestion, levels of severity do not equal levels of terror, confusion, or struggling for engineers. These do not track together. In fact, quite often what we'll see is definitions of severity, reasonably so, up until now, almost entirely track with customer impact. Again, this is fine and totally reasonable. But can you imagine, engage some imagination, can you imagine an event that has no customer impact, but can be absolutely existential? As an example, if you were to discover today that every piece of critical production data, their backups are corrupted, there is no customer impact. 0 customers are impacted. There will be impacted if you lose a database. So what are you going to call that? You're not going to call that a Sev 1? You are one database away from possibly a viability crushing event. Find the shape of how these are different. Ask your organization, ask the people who are really familiar with the work, what keeps you up at night? What really worries you? And you'll find that they do not map to the accounting of severity and all of the other sort of metrics. I'm going to skip over these. I don't know how that was weird, right? You'll be able to see the slides, I'll post them. I've got 2 slides left, and they're pretty straightforward. And they're really more like a strong request to the industry. Stop looking for a root cause, okay? Looking for a root cause is an indication that you're not interested in learning. You're looking for quick closure. If you want to have quick closure and a simplistic explanation for what is essentially a complex event, go for it. Just don't say root cause. Human error is not a thing. I don't have time to explain that. It's not. So, thanks for listening.